Hi friends, today we are discussing about plasma arc welding process. In this session, we are dealing with the principle, different types, the different parameters, advantages, disadvantages and applications of plasma arc welding. So first of all, what is a plasma arc welding? It is a liquid state welding process to join the metal to metal in the molten state. So the hot ionized gas is normally called as plasma and it is used as a medium to join the metals. So this is the figure of the plasma arc welding process. So it's already mentioned that it is a liquid state welding process and the metal to metal joining process is happening here. So normally the hot ionized gas is known as the fourth state of matter after the liquid, solid and gas. So how the hot ionized gas is formed, that is how the plasma is formed. When a certain amount of energy is fed to the inert gases, the electrons emits from the atoms. After the emission of the electrons, that particular atoms are converted into hot ionized gas. So this is known as high plasma and this have high energy content. So normally this high energy content plasma, that is the hot ionized gas, is used to heat the workpiece, and the joining process is done by the fusion process. So this is the basic principle of plasma arc welding process. When we are looking into the figure, we can see that the plasma arc welding gas, that is plasma gas, and the shielding gas, then the non-consumable tungsten electrode, and non-consumable electrode is the, then a water cooled nozzle is the, then a weld pool, the plasma, this is power supply. This is the basic arrangement of a plasma arc welding process. First of all, the plasma arc welding process works on the DC power supply, and the plasma gas, that is the inert gas, otherwise the hot ionized gas, and the shielding gas are normally, both the gases have normally the inert gases like argon, helium, etc. The shielding gas is provided in order to prevent the oxidation of the weld pool, otherwise the welding area, and to protect it from other contaminants. So this plasma arc welding process is almost similar to, otherwise it is similar to the tungsten, that is stick welding, tungsten inert gas welding, except in plasma arc welding, if the plasma used instead of arc in the TIG welding process. So as you all know that it is a high energy content gas, so normally the temperature rises up to nearly 30 degrees Celsius. So this has been cooled by the plasma arc, otherwise the plasma arc shield should be cooled by something like water. So a constructing water cooled nozzle is placed near to the plasma arc welding process. This is the other figure of a plasma arc welding. Little bit explanatory. So the plasma arc, that is otherwise the hot ionized gas, is directly fed into the workpiece where it should be welded, and it should be cooled by the water jet, and the outer of that particular arc should be shielded by the shielding gas like argon or helium, etc. So this is the basic principle. Then normally the plasma arc welding process are classified into two types, that is transferred plasma arc welding process, and the second one is non-transferred plasma arc welding process. The basic difference in these two types is the polarity difference, that is the connection of the positive and negative terminals. So this is the figure of the transferred and non-transferred arc welding process. In the first type, that is the transferred arc welding process, the negative terminal is connected to the electrode and the workpiece is connected to the positive terminal. And the second type, that is non-transfer type, the electrode is connected to the negative and the constricting nozzle is connected to the positive. This is the basic difference in the connection of these two types of plasma arc welding process. So for the explanatory part, this is the transferred plasma arc weld uses direct polarity, that is the DC current. The tungsten electrode can be allied to the negative terminal and the metal, that is the workpieces, can be allied to the positive terminal. The arc produces among the tungsten electrode as well as the work portion. So in this kind of method, both arc and plasma move towards the work portion, which will enhance the heating capacity of the method. So this can be used to join the thick sheets, that is otherwise the solid sheets. And the second type, that is the non-transferred plasma arc welding process. The basic difference is the connection of the positive and negative terminals. In this section, the tungsten electrode is connected to the negative and the nozzle is connected to the positive terminal. So generally the arc produces between the nozzle and the tungsten electrode, which enhances the ionization of the gas within the torch. So this method can be used to join the thin sheets. So this is the basic difference between the transferred and the non-transferred plasma arc welding process. This is the main parts of the plasma arc welding process. For the first one is film material. In general, in plasma arc welding process, there may not be used the film material. Normally, there is no use of film material, but in some cases, film material can be used, and that can be incorporated with the help manually. Then the power supply. Generally, DC power supply is used. When compared to the TIG welding, low current consumption is not in this particular type, and the plasma console, the equipment. Then water recirculator, plasma welding torch, and torch accessory kits. These are the main parts of the plasma arc welding process. And this is the welding parameters. Then generally the current comes from 50 to 350 amps and voltage from 27 to 31 volts, and the temperature rises to nearly 30,000 degrees Celsius. This is the basic type. So in general, at the last, normally we have already told that the plasma arc welding, simply the PAW, is similar to the TIG welding. So generally, this is the difference between the PAW and the TIG welding. First of all, the plasma arc welding, there are two gases are used. One for the plasma, that is one for the plasma generation, that is for the ionized gas, and second one is for the shielding gas. But in the case of TIG welding, only one gas is used, that which forms the plasma and the shield as well as the shield. The arc and mortar weld, only one typing gas. Okay, in case of plasma arc welding, that is PAW, constant arc is maintained, but in TIG welding it is not constant arc. Temperature is 11,000 degrees Celsius and rises up to nearly 28 or to 30 degrees Celsius, but in TIG that is about nearly 4,000 degrees Celsius. In this case, PAW, high ionized gas is used, that is a high content of energy is released, that should be possible, and it incorporates the deep penetration. But in this case there is no high temperature, so which results in the much low penetration method. In this PAW, no film material is used. Here more film material is used. Then other advantages includes the fast metal deposition rate, unit gas consumption is very high, costly of the welding equipment. Others, on behalf of TIG welding, metal deposition rate is not so faster, unit gas consumption is very low, less costly equipment, cutting of hard and brittle material is not possible. This is the basic difference between the TIG and the plasma arc welding process. And then coming to the advantages, already mentioned the advantages and disadvantages of plasma arc welding in comparison with the TIG welding. So And finally, the advantages of plasma arc welding are, some of them are: metal deposition rate is very high, uniform penetration with a high welding rate is possible, stability of the arc, etc. The process is very fast and clean, less operator skill is necessary, high penetration capability. The second one is disadvantages. It's high energy content gas, so special protection is necessary. High power electrical equipment is necessary because it rises up to nearly 28 to 30 degrees Celsius. Gives out ultraviolet and infrared radiation, which is harmful to the normal eye. Otherwise, direct contact is dangerous. Operation produces that noise, expensive equipment, etc. Then application type, it can be used in aerospace industries, food and stuff, chemical, mission and plant construction, etc. These are the advantages, disadvantages and applications of plasma arc welding process. Okay, thank you.